All right, we're live.
Right, we're live. Here we go.
Hello, everybody, and welcome to another great workshop. Today we've got Quentin Tabaka from the Alby team. He is the head of Lightning operations at Alby, and he's going to be giving us an introduction to Kubernetes. I hope I'm pronouncing that right, by the way.
Yeah.
It's going to be a sort of a technical workshop, following him live with his code on how to set up sort of enterprise level infrastructure for Lightning payments in companies. So this is supposedly what companies like Cash App, Strike, and some others will sort of implement, or something close to it. So if you are looking for that kind of infrastructure, this is definitely going to be a really good way to get you set up. I'll hand it over to Quentin. Quentin, it's great to have you. Thank you very much for giving your time today. And yeah, I'll give you the floor.
All right. Thank you, Ed. Thank you so much to be here. So, okay, like Ed was saying, I'm Quentin. I'm from Belgium. I work at Alby, where I'm the head of Lightning operations. So where I'm doing mainly backend engineering and DevOps engineering, of which we are also going to do today. That means that I'm responsible for everything that runs in the clouds. So if you use Alby, you can connect your own node, but you can also use our infrastructure. And that's the kind of infrastructure that we are going to set up today. So I will now share my screen. And okay, so you should be seeing my screen right now. Is that right, Ed? It's okay, right?
Yeah.
Okay.
Okay, I'll drop the background and give it to you.
So I don't know, because I'm a bit in the dark because I only have a single screen myself. But in case if there are, I would like to know someone, or if there are any people that are following and that want to follow live, like try to keep up live. That's possible. It's going to be challenging, but it's possible. But you can always afterwards watch the YouTube stream again. So let's get started, I guess, because we have quite a few things to do. So if you create a DigitalOcean account, then this is just go to digitalocean.com or cloud@digitalocean.com and create an account. You can sign in with Google, with GitHub. And once you've done that, you also need to add a payment method, because what we're going to do is not free. You will have to pay for the resources for the virtual machines that we're going to use. You can use a credit card or PayPal, but that will be necessary. So if you have done all that, then you should be also looking at the same screen that I am looking at now. And it says, welcome to DigitalOcean. So DigitalOcean is a cloud provider which is similar to Amazon AWS or Google Cloud or Microsoft Azure. But it's one that I like to use because it's quite simple. It has a good UI and it has everything that you need, basically. And it's not a super big player. But if you really want high level reliability, uptime, all super many features, then you would go to more like Google Cloud or something like that. But right now, for what I like to do is use DigitalOcean. So what we're going to do today is we are going to create a Kubernetes cluster. We are going to create a GitHub repository. We are going to push some Helm manifests to that GitHub repository, which that is, I will explain later. And we are going to connect the GitHub repository to the DigitalOcean cluster that we created. And then we will do something which is called CI/CD, which means continuous integration, continuous deployment, which means that anytime that we push code to the GitHub repository, the code will be automatically deployed to the production cluster. So The only thing that you as a programmer need to do is make a commit, push it to the GitHub repository, and then everything will be handled automatically, and the new configuration of the system will be installed and will be live automatically within a couple of minutes. And this is something which is called continuous deployment. And this is really a paradigm of modern software engineering, where you have many people working together in a team. They are so everyone is working in their teams, but they also all need to contribute and to orchestrate all of this, to enable teams to push out features independently. There is this thing, this paradigm, which is called continuous integration, continuous deployment. Continuous integration means that you build your code automatically. Continuous deployment means that you deploy your code automatically. And so what we are going to do here is really see an introduction to that, really. So what you will need to do is you will need to go here to control panel, and then you go to the control panel. So this is a brand new account that I set up and will also delete afterwards. So I will also sometimes need to stop sharing my screen when there is sensitive info. It won't be that sensitive because I will delete everything afterwards. But we might use the plan is to use mainnets, lightning nodes, and to maybe open a real channel to make things interesting. So let's see what we can do there. So you are right here, and what you want to do is you want to go to Kubernetes. And we are now going to install Kubernetes in minutes, as is advised here. What is Kubernetes? Kubernetes is a way to deploy software at scale. It's been developed by Google. And what you can do is that you can what is called containerize your application, like put it in a container. And then Kubernetes is a container orchestration tool. So what that means is that it's the same thing. It's like a virtual cloud environment where there are many different nodes. Let's say a node goes down, then another node automatically gets booted up. Even better, every workload that was running on the first node will be transferred to a new node automatically. So there are certain features inside Kubernetes that make it attractive to deploy software at scale. So automatic reboot, rebalancing. You can really scale up. So let's say you don't want to run one Lightning node, but you want to run 20 or 50. And if you're thinking that's something that is far-fetched, this is what people at Cash App are doing today. But to do this, you would need to really design your software in such a way that it is that it can be scaled in such a way on a Kubernetes cluster. Cash App has those kind of things. There is a talk also by Ryan Lumba. It was at Austin last year, I think. And there he explains everything, how they do these kind of things. What we are going to do today is we're going to install LND in a Kubernetes cluster. This is something that is not really designed to scale as well as what people are doing at the Cash App. So there are certain trade-offs that people in LND, which is kind of the most generic Lightning software, they have made. But we can still install it in Kubernetes and try and get a large amount of the benefits, not all of them. And the people at Lightning Labs are certainly working on making this more scalable. But just I wanted to say that you can do this LND run on Kubernetes. An example of a really, really high word level way of doing this would be the stuff that people are using at the Cash App. But basically, that's what Kubernetes is. So we want to create a Kubernetes cluster. We don't want to be in San Francisco. We want to be in Amsterdam. That's much nicer. So this will cost some money. I will tear this down once this day is over, so it's not going to cost me that much money. You can take some smaller plans, but I had some problems with installing stuff on the smaller nodes. If I only took one and I only took the small one, this will only cost you $12 a month. It should be possible in theory to run LND on such a cluster, which is not really cluster because it only has one node. But I would now, to just make sure that nothing goes wrong, I want to use this one, and I also want 3 nodes. So just to be sure. And then you have all these kind of things. We don't really need that. We don't really need that. We need to name it, and we're going to name it Bolt Fun Demo. And it's in project, my first project, doesn't matter. And we are going to create this cluster. Okay, we're here, and it has been created. So what you will, we can click on Get Started, and then we want to connect and manage this cluster. So what they are recommend here is using the Kubernetes official client and DigitalOcean's command line tool Doctal. So what we want to do is we want to install and configure Doctal. If you are on macOS, you can do that by brew install Doctal. I already have it installed, but to do that, you can just do this. And once you've done that, you need to create an API token. So to create an API token, we will go to API here. The cluster is, at this moment, the cluster is still being provisioned, so it's not ready yet. And then we want to generate a new token. So I want to give it a name, Bolt Fun. Doctal Bolt Fun or something like that. And when I now click generate token, the token will be shown on my screen. So that's why I will now stop sharing for a minute and actually do this. And now it's on my screen, and I will now copy this token and go to my terminal, and then just do this. Okay, so I will now reshare my screen again. Okay, so we should be good again, I guess. Oh, yeah, okay, I did it anyway. So what we now want to do is do Doctal. Let me stop sharing for a second to be sure. Well, it doesn't really matter. I'm going to tear this down anyway. Init. Yeah, okay. So, okay, let me share again. Okay, so what I just did was I've installed Doctal with brew install Doctal, and then I did a Doctal auth init context Bolt Fun. This name Bolt Fun you can pick yourself. Let me just go back here, and then go back here, and then I pasted in this access token that I just created. And now this has been created. So what we can now do is we can say Doctal Kubernetes cluster lists, and we should see our Kubernetes cluster that is just being provisioned, which is still being provisioned, show up. So we did a Doctal Kubernetes cluster list, and it's still being provisioned. So we cannot yet see it. Let me stop sharing for a minute, and let me go back to this place. Okay. Okay, and then what we also want to do is just share my screen again. Okay, and so what we will also need is something called kubectl. So the Kubernetes command line tool, kubectl, is something that we will is really the client that you will need to look at your Kubernetes cluster in the command line. So we can install it on Linux, we can install it on macOS, we can install it on Windows. If anyone is wanting to do this on Windows, you have my uttermost respect, but I cannot do it myself. So basically, you will need Linux, Ubuntu, or macOS. I have never seen someone do this on Windows. It is possible in theory, of course. Many people do it. But if you want to do that on Windows, you can maybe consider installing Linux first as a subsystem on Windows, and then using Linux to follow along. So I would recommend that instead of directly using Windows. So, but if you've installed this kubectl, then you can do all kinds of kubectl commands. But for that, we obviously need first access to this cluster, which is actually still provisioning. So we need to wait a bit until it is ready, but it should be ready quite soon. We can even try it. So now we've done what they say over here. So we can try to connect our cluster here using this command. And this should be now okay. And we can do a kubectl get namespaces. And this should work in theory. Okay, so we have now an empty cluster, so with some namespaces. So we have the default namespace and then some behind the scenes boiler room namespaces, which are not really important. So what we can also do is the most basic command, which is called kubectl get pods. And pods are really containers, applications that you will deploy, or instances of applications that you will deploy inside your cluster. And as you can see, we are now inside the cluster, but there are no resources found in the default namespace, which is perfectly normal because we haven't installed them yet. So now what we are going to do now, let me just have a look. And we are already at step 3, so that's fine. What we're now going to do is that we are needing yet another command line tool, which is called Helm. So Kubernetes has a very rich ecosystem around it. There is also a very good honeypot documentary about it if you want to look at it, which is like very funny documentary. It was actually first used to run Pokemon Go by the people at Nintendo. Well, after it was developed by Google, of course. And so what we are going to do is we are going to install things using Helm. And Helm is like a step above kubectl. And so it's really to be able to install large amounts of stuff, which you can technically do with kubectl. But to make it easier for you, you are better off doing it with Helm. So you can this page, helm.sh, as all kinds of info on how to install Helm. You can, the easiest thing, if you're on Mac OS, you can brew install Helm. If you're on Ubuntu, you can sudo apt-get install Helm. So that seems to be the easiest thing for me. But I've already installed it, so we can go right ahead and use it. Let me check my version. Oh, Versino, that doesn't exist. This also doesn't exist, it's just version. Okay, so basically we are in some version 3.4.2. So what we are going to do right now is that we are going to create a repository, which we will call lnk8s. That one that you see is one that I created just an hour ago to pre-run all this stuff. So what we want to do is we want to do Helm create lnk8s. We are, and as you can see, a new directory has showed up. So we are going to open that directory. Something else that you will need is called Visual Studio Codes, which I have installed, which is this icon over here, which I think many programmers will be familiar with. If you're not, then you can easily install it. But that's not, well, that's something that is out of the scope of this video, but it's not that hard. So what you want to do is now open this directory using Visual Studio Code. And we've opened this directory, and as we can see, what do we have here? So this is the standard directory, standard things that you see when you have just created a Helm chart. So we are creating charts. Basically, there is this chart.yaml file. So these are all YAML files, which is a way to describe config. We are only going to program config today. We are not going to use any real programming languages. YAML is short for YAML ain't markup language, which is a recursive acronym, but this is totally side info. So what this has generated all kinds of code that we totally don't need. So we are going to just delete this. And we are also going to delete all the files that are in here. Delete, let me just, templates, we don't need these templates, and we are going to delete everything, every one of these. So we don't have any templates anymore. Okay, so that's that. So what do we want to do now? Now we actually, okay, so what we want to do is we want to make this directory into a Git repository. So one thing that you will also need is Git, which is standard, which is the most common piece of software in a software developer's toolkit. So what you do is git init, and you want to add everything, and you want to make the first commit, which you choose just like this, and that's that. And what you want to do then is you want to go to github.com, and you want to create a new repository, and you want to call that something that you choose. And I will now choose this one and actually create it right now. If there are any questions or something like that, just let me know, or if I'm going too fast or anything like that. I don't have a lot of feedback here. I'm just talking into my screen. I only have a single screen, so yeah. But I am now going to push an existing repository from the command line, because we have all just created it. And for that to do, you need to do this. And now it's pushed. So if I refresh this page, then everything should be here, and it's there. So that is actually great. So what do we want to do now? We've created a GitHub repository. We've made it using Helm. So that's all fine. Okay, now we actually want to install something, right? What are we going to install in this repository? Well, I guess we are going to install LND, which you might be familiar with. So in order to do that, we will need two things. So first, we will need to describe LND in this chart.yaml plus values.yaml file. And then we will need to add a new file, which is called the GitHub action workflow. GitHub action is a system that is used by GitHub that you can use to automatically deploy or do all kinds of stuff, compute. And we are going to use that to automatically deploy what we've described in this chart.yaml and values.yaml file to our DigitalOcean accounts. So what are we going to do first? I guess we can start with the GitHub action workflow and keep the Lightning stuff for later. So what we actually want to do is we want to go and look at this tests repository, because I have some small sheets over here. Sorry, GitHub workflows. And this is what we actually want to use. So we are going to deploy the bolt.fun. Make this and touch. Okay, we create some folders. We create a file called deploy.yaml, and we want to copy paste this correctly. And so let me go over it right now. So let's say today we are deploying the bolt.fun platform. And then this is some it's some language. It's not a programming language. It's some configuration language. It's YAML actually, I think, and it is actually being it's used to describe what you want to do. This doesn't do anything. Okay, whatever. So it's used to describe the actions that you want GitHub actions to actually do. So here we describe when we want to do these actions, and we want to do these actions when we push code to our main branch. And here we describe what we are going to do. We are going to have some environment variables, both from demo. Chart name is dot, because we are inside the same directory, and that's called dots. and then the release name is some name that you can choose. The namespace, we are not going to use a special namespace to organize stuff. We are just going to use the default namespace. We want to use Ubuntu to do all these things. And then what we want to do is we want to actually save our DigitalOcean kube config, which is, so you can all use this kind of pre-built actions that is yeah, so to set up the connection between your GitHub account and your DigitalOcean account, you can use this action. And then this action will need an access token, which we will create later. Now this is not very important, basically, but what we are going to do is we're going to install Helm, which you can also use some GitHub action for, and you need to specify what versions of this you want to use, but that's not very important. What we're going to do is we're going to add some repository. So this is my repository where I have all kinds of Helm charts. Let me show you Helm charts. So I have this collection of all kinds of different Helm charts. So we can install all kinds of things. Most of them are Bitcoin or Lightning related. Yeah, I guess we can go over them. So basically, I have C Lightning, you have Eclair here, you have LND Hub, you have some kind of more generic stuff, and Bitcoin D as well. So this is all open source. Fritz is the name of my personal company, which this is basically my collection of Helm charts that we also use at Alby professionally. So, what we want to do here is we actually want to add this repository so we can fetch from these charts. And then this is something, yeah, it's not very important. And then we want to install these charts into the Kubernetes cluster. So if you're going to look at what we're actually installing, and well, I guess we're still okay, right? Yeah, okay. So let me just go on then, I guess. If there is something, then I guess Ed should ping me on Slack, but I think I don't hear anything, so I suspect that everything is still going on.
No questions as of yet.
Oh,
Quentin,
okay,
so,
okay. Thank you, Ed. Thank you so much for yeah, because I don't know if I see them sharing, but there is very little feedback. But okay, let's keep on going then. Okay, so let's see what we are actually going to install. We are going to install a deployment. This is all not very important, really, but the most important thing is what we have here. And what we have here is containers. And this is the LND container. So this is the heart of everything. So you specify a container, you specify a command that will run in this container, and this container will just run LND. And you specify some ports that can be used to listen to this, to interact with this container. You specify some volume mounts, which you will need actually to, because a Kubernetes container is something very short-lived. It can be killed and then it will be automatically rebooted. So if you don't specify any volume mounts, then your data, even if you write data to your disk, it won't be persisted. And that's obviously something that we do not want, of course. So we need to specify a volume to be mounted to write this data to. Normally, this is a bit of an anti-pattern, I would say. Normally, if you install things in Kubernetes, to be able to really leverage Kubernetes, you don't want to mount volumes. What you want to do is you want to store all your data in a separate database, a real PostgreSQL database that is something running somewhere else, or maybe even also in your cluster, doesn't really matter. But what you really want to do is separate this more than what we are doing right now. And LND since a couple of months, LND does have support, but I guess partial support for not mounting volumes anymore and storing your channel data inside Postgres. C-Lightning has had support for that for a long time. I also have some C-Lightning charts to install C-Lightning Kubernetes. And Eclair also has support to store stuff in Postgres, but I'm not entirely sure. I don't think that you can just, when you're using C-Lightning or Eclair, that you can just not use any mounted volumes. I'm not really sure about that. But basically, that's the story about this. You need them, but actually, if you really want to do something at scale, for example, the people at the Cache App, they use a MySQL database and other stuff, but things like that. So that's the story about that. So this chart has support for lit, it has support for LND backup, it has support for auto unlock, it has support for all kinds of things. I even have write a Lightning interface here. I have an LND Mon, which is something for Grafana. So there are all kinds of supporting services here, but let's keep it simple for now and let's use just LND. And here you in the values.yaml, you're supposed to describe your configuration. So what we want is we want to use Lightning Labs official Docker image, and we want to use this tag, which is the latest tag, which is very important if you don't want, if you want to be up to date and not unsynced to the chain because of the bug of last week. So and here we have everything that is needed to describe, basically to describe your configuration of your Lightning node. So basically, it's not very important except for persistence, which is 5 gigabytes of persistence. This is the default of the chart. We are going to override some of these things in a moment. And what is also important is the load balancer, which is something which DigitalOcean will provision for us. So because we specify here this thing called a load balancer, DigitalOcean will automatically give us a static IP address. And this is important so our Lightning node can listen on ClearNet to the Lightning network for the peer-to-peer messages on port 9735, which is the default. And basically, DigitalOcean will automatically give us a static IP address that we can use. And our nodes, well, this is something that they do, and it's very easy to get up and running pretty soon. So basically, that's the story of this Helm stuff. But what we are now going to do is, okay, we've described our action to deploy this in the cluster, but what we're now going to do is we are going to describe our configuration of the Lightning nodes. So I will now sneak a bit into my other repository. What we have here is called values.yaml, and we actually want to copy this one. Sorry. And we also want to copy the charts.yaml. Yeah, we want to install some dependencies. Okay. And okay, so right now, okay, that's actually everything that we have to do. So what we've done right now is, okay, we in chart.yaml, which is just the list of everything that we're going to install under dependencies, we are going to install LND. We are going to install the version, which is the version of the chart, not the version of LND itself. And this is just some internal version that I use for these charts. And we're going to give it an alias because let's say we want to use run LND2 as well, then that's certainly possible. And what we've done here is you use the same alias here. So on the top level, you use the same alias. So you're using LND1. You want to, and here, this is your LND configuration file, which we can go over in a minute. We don't want to auto-unlock, which is possible, but it's not possible on the first install of the wallet. And here we want to specify some resources. So a thing about these resources is that it's very important that you specify them. In most cases, it's good practice to specify them. Oh, sorry, there is some, actually, I see that there is an indentation problem here. Okay, so yeah, I think that's better. Okay, so what we're saying here is we request from Kubernetes a certain memory, a certain amount of memory and a certain amount of CPU to be allocated to this Lightning nodes. I hope this will be not cause any trouble. This is quite high actually, but I don't want it to be slow or to crash. So let's see if it works. But you also want to specify some limits, so which is the maximum amount of memory and maximum amount of CPU that your pod is allowed to use. And this is important because if you don't do this and things you have some kind of memory leak in your pod, then Kubernetes cannot very well handle it. It might become a bit rough or a bit dirty in your cluster, and it can start to impact other pods that are running in your cluster. But if you specify these limits, then Kubernetes can very easily say, okay, this pod is having a memory leak, it's causing way too much resources, and we are going to just kill it and restart it. And if it does it again, we're going to kill it again and restart it again. And like this, you can really you can minimize the chance that if there is something wrong in one pod with a memory, it won't bring down everything else in the cluster. So that's why it's best to specify this. Then we can go over this configuration, which most people should be familiar with, which is just the same configuration as is the standard in LND, really. So you want to be on Bitcoin, you don't want to be on Litecoin, Lightning Network, because, yeah, it's a bit of a ghost town over there. You want to be either on mainnet or on testnet. Right now we are on testnet, but I think I'm just going to share, like YOLO, right? We are just going to use mainnet over here. So we want to use debug level info. We want to use Neutrino because we currently don't have a full node running. If you want to use Bitcoin as a backend, you first need to install a full node. To install a full node on Kubernetes is something that you can do, but will cost you a lot of resources because running a full node in the cloud is not that cheap. And certainly if you use a full node on Kubernetes, it's not going to be that cheap. It's not going to be the cheapest option, but you can certainly do it. And we want to add some peers, but actually I need to look up if this is probably testnet peers. So I am going to add some new peers. Let me just look it up on Alex Bosworth's guide in a second. And these are some extra domains that you can use, but this is still from Fold actually, but these are, I'm just going to delete these because I don't think we are going to be using them. So that's out of the scope. We want Wimbo channels, of course. We don't want Prometheus, and that's everything. So let me just Alex Bosworth run LND and look at this guide, which is very useful for what to do if we want to run LND. We want to use Neutrino to add some peers. Yeah, okay, so let's just add these peers, which is like the mainnet peers that we can use, and I hope that some of them work, I guess. Which is mainly the infrastructure that is run by the people at Strike. So let's see, this should work. So now we have an entire configuration on mainnet of this LND node, and in theory, this should work. And right now we're going to mainnet install LND. And then we are just going to push this to our repository and see what happens. And obviously, it won't work from the first time, which it never does. And I know it won't because I've actually, I know what we forgot. We forgot something. Let me have a look. Okay, so we can see it's pending. So we need to go to actions in our GitHub repository, and we can see here that it's actually running, which is good. But it's running. But you can see all the steps that we defined here, and it's going to install them, which takes a while. So these are not very powerful machines. It takes some time to do these kind of things. And what it's right now doing is it's installing all these things that we told it to install: Doctal, Helm, kubectl, etc., etc. And now it wants to do something, namely this, but this will fail. Of course, it will fail because we forgot something, and what we forgot is that the DigitalOcean access token environment variable must be set, of course. So I am actually going to do that. So what you want to do is you want to go to settings, and then you want to go to secrets and actions, and there are no repository secrets yet. So you want to add one, and if you went and had a look at what we did here, it was called DO access token. So you want to put DO access token as the name here, and what you want to do then is you want to go back to your DigitalOcean account on the API section, and then you want to basically you want to add a new personal access token. And let me just do that again. It's the same thing as we actually did the previous time. And you can call it GitHub Actions or something. And I think it would be interesting if there's someone watching who saw the previous token and is now already hacking my cluster. If they manage to hack the cluster before I get it down, then that will be very impressive. But in that case, you should contact me as well. But let's try it, right? Let's try it, I guess. So I'm going back to GitHub and pasting this token that I just created right now. And now I've actually done that. And let me share my screen again. My entire screen. Okay. So, oh, sorry. Yeah, okay. So we added the repository secrets, which you cannot read anymore for security reasons. And we want to try this again. We don't have any new code, so we can just try to rerun all jobs here. And let's see what happens. It should try again, and it should actually work this time, unless there's something that we still forgot. And now we have to wait a bit, which is, yeah, it's part of the DevOps lifestyle to wait a bit for something to action to complete. Everything's still okay, Ed, over there? Maybe Ed went to get some coffee. I don't know.
All good. All good.
All right. That's fine.
No news is good news.
Yeah, indeed. All right, so this is actually doing something. We are installing the bolt.fun stack, and it actually has installed the bolt.fun stack. So what we want to do is we want to look at what we actually installed. Let's do a kubectl get pods and see. And right now we can see there is actually something here. Okay, so we have two things here. There is this. Okay, so there is something here that shouldn't be here, and there is something here that is here. So we actually have yeah, okay. I don't know why that is there. It's a bug in my code. So we have an LND node which is initting, and we also have an RTL. I don't know why this lightning pot is here. I really have no idea. I thought I had disabled it, but I have not disabled it. So let's try to disable it for real this time. And let's RTL enable false, I guess, and disable RTL. I don't know if this will work. There's some bug in this, but it's not that important. This container will probably not boot up because I think installing RTL is a bit too much for this video. But it's there. It doesn't really matter. Yeah. So don't mind that one. But we have good news, really. And the good news is that we have an LND node, which is actually running. And it should be running on, well, it's not running yet, but it's actually running. And so we can look at the logs, actually. And to do that, you do kubectl. Sorry about this. You can do a kubectl logs bolt fun demo LND1. So if you get the pods, you get the name of the pods, and if you then do a kubectl logs name of the pods, you can look at the logs of the pods, and this is something which some people might be familiar with, and it is a very good sign because it means that LND has started up. So we are on version 0.15.2. We are active on mainnet. Reckless. We have opened the Beeble database, which took a very short time because the Beeble database is still empty, unlike it can take some very long times if you have a big database. But we are waiting for a wallet encryption password. So we want to LNCLI to create a wallet and so on. And actually, I am going to do that right now. And I won't show you the seed, but I am going to open a shell, which you can do by kubectl exec. So we are SSHing into the pod. And then we are going to show you some, I am going to do an LNCLI create, which many people have done before probably. And I will use some passwords. Okay, I don't have a seed, no, and I am not even going to save the seed, whatever. Okay, so LND is showing me the seed, and now LND has initialized, and I'm going back out of the shell and sharing my screen again. All right, so we're back, like we never left. And what you want to do now is you want to, okay, so if you see me typing K, it's the same as kubectl. Right now we can see that our RTL has now gone because I deleted it. So that's good. And what we actually want to do is we want to look at logs, but the logs of LND will indicate that everything is fine, I think. So what we actually want to do is we want to open another shell like I did before to go inside. And if you are inside, then you can do this LNCLI commands like you could do anywhere. And as you can see, we are just using LNCLI get info. And what we are seeing here is that this is our pub key. We don't really have an alias, but you can specify an alias if you want. And basically, we have a pub key, and we are on a Bitcoin mainnet, so we can start doing some real cool stuff right now. So if you do like LNCLI list channels, then you will see that we don't have any channels yet. But I think that we can now start to open some channels, and we can do an LNCLI list peers, but we don't have any peers yet. So we can also do that. Let me have a look. What are we? Okay, so this is, I think, yeah, you can do everything that you want right now. So we are actually successful. So this actually concludes the first part of the workshop, which is actually something that is already very, very cool accomplishment. So what we actually want to do, okay, so we've done all of this. And then that's actually fine. So what do we want to do now? What do we want to do next? That's a good question. We have a node, so let's get some money on it, I guess. We can, so now we can really, if you like, you can really get going now. You can install C Lightning, you can install Eclair, you can install LND Hub, you can install Write Lightning, you can install Thunder Hub, you can install databases, everything that you want. Basically, you can do. But what I think would be interesting is that we would maybe update our alias. Alias equals bolt.fun.demo. .kubernetes.demo. Yeah, that's just that people can see our node in the real world. So that's just a small. Okay, so no, sorry. But I get it. We can, yeah. So there is still something to do. We can do auto unlock passwords. But for that, okay, so I will now tell you the password that I used to auto unlock it, which is not really a big thing, I guess, maybe unless you're hacking the cluster already. But I actually used Vault. It doesn't really matter, I guess. Okay, this is the password. We want to auto unlock it, and that should be good. And the config. Okay, so now what we did right now is something which really illustrates the power of CI/CD and automatic deployment on Kubernetes. We want to make some changes to our configuration. We forgot our alias. So it's really simple. As you could see, I did it in 20 seconds. I just wrote alias, what I want the alias to be, and I changed some stuff here. And then I just do a git commit, git push. And right now, this is happening as we speak. The Github is deploying these and will automatically reboot our Lightning nodes to be able to conform to this new configuration. And right here, you can really see the problem. Sorry, the potential of this workflow. So to really, for example, you could even have because right now I push to the main branch directly. Normally, in an organization that is large enough, then I wouldn't even be able to do this. This would be locked down. What I would do is I would make a pull request and ask someone to review my pull request. And only when when enough people have reviewed and approved of my pull request, then I would be able to merge the pull requests. And this is all done in the same ethos as open source collaboration. Once enough people have reviewed and approved it, it will be merged and it will be automatically deployed. And this is something which is really called not really infrastructure as code, but it's one of the tenets of continuous deployment, really. So as we can see, this thing is already deployed, our LND node, and it's actually already up for already a minute. So if we now do a get info call, then we should see the new alias of the node. And yeah, it's indeed bolted funded K8s, the demo. So what we now, something that I forgot is we want to look at what we are actually using. So I now do a kget persistent volume claim. I can also watch this over here. The volume that I mentioned before that we created, where we actually store our data, is automatically provisioned by DigitalOcean, which I think is very, very nice. So we have here some 5 gigabytes disk, which we just created automatically. So that's something really cool. And there is also networking. And as we saw before, I mentioned that I wanted to create a load balancer. And by just mentioning that in the Helm chart, DigitalOcean automatically created a load balancer for us, which is also very cool. Disclaimer though, this stuff all costs money. So load balancer costs money. We have even the load balancer on 3 nodes, so that's 3 times the amount of money. I think it's only $10 each per month or something, but this can all add up, so be warned about this. And this obviously also costs money. But that's really it for this. And so what we want to do now is, I guess we want to open a channel, and where else to open channel than to go to lnbig.com. That's where you need to be if you want to open channels, right? Or Amboss, but that's going to take too long. So what do we want here? We actually want some, let's say, I don't know. Okay, this might be. I don't want to be overkill here because we're going to shut this down. So let's say 500,000 or something. Small channel. But let's agree to the terms, I guess. We actually want to, yeah, okay, I guess it's fine. I will use my Alby browser extension to, no, I don't want to use Zap. Oh shit. Okay, let's just, okay, I'll be back. No, I don't want to, okay, just let me, okay, this obviously doesn't really work, but I just want to pay this with Alby. Let's pay over Lightning. Okay, so we want to actually, I guess what do we want to do here? We want to connect to Alan Big, but we are not connected yet. Oh, we are connected, I guess. Okay, we want to make this a public or private channel. I guess it doesn't really matter. Okay, this supposedly this all works. So yeah, node ID at host port. We want to do this. And then we want to do LNCLI, no, sorry, LNCLI connects to this peer. And okay, this doesn't work. Okay, why doesn't this work? Because we are not, okay, there was something wrong, because we are not, the server is still in the process of starting. So LND is not ready yet, but it's running. So we did have a get info, but it's probably not synced to the network yet. Okay, so sync to graph false. So yeah, what can I say? Basically, we need to wait for LND to sync to the graph, which is very boring. It should be synced to the graph immediately. Like, get your shit together. No, I'm kidding. Okay, so we need to wait for LND to be synced to the graph before we actually want to we are able to do something. So that's a bummer. But yeah, I guess we want to wait a bit. Do we want to do something else? Maybe we do. Why not? Okay, I don't know how long this is going to take. Okay. It's syncing to the graph. So this I don't know how long this will take. Let's yeah. So we can sit here around and wait for LND to sync, or we can install C Lightning, I guess. It's still only at block height 408,000. So this is something that I didn't consider, because we are currently at block heights almost 700,000, around 700,000, I guess. So this thing has a long way to go to sync to the chain and to the graph. So let's try our luck with C Lightning, I guess. So what we want is that, okay, this is something that I didn't really prepare. Okay, Mr. OX50, you're a cloud consultant. This is pretty interesting. I use Kubernetes and Helm every day. Well, thank you. I also use it every day, and a lot of people do. So if you are interested in this, then yeah, I guess there are super many opportunities in the space for you to get started with this. Okay, so now I actually want to go and look at some of my other code where I've already installed C Lightning, and let's try that one. Okay. And yeah, sorry, I just don't want to show anything that might be not a good idea to show. Okay, here. Okay. If this is wrong, yeah, okay. Yeah, sorry, okay, so we are going to install CLightning. Yeah, okay. Sorry about this. That should be fine. Okay. Okay. We don't want this. No, sorry. Oh. Payment failed. Oh, okay. So we, yeah, so sorry, our payment or HODL invoice for the LNBIC just failed because, well, we just didn't do anything because LND was still booting, which is something that I hadn't considered. But that's fine, I guess. Okay, so what we want to do, okay, let me share my screen again. Sorry about this. Okay, so let's go ahead and look at how to install CLightning. So this is also that really shows how easy it is to do large amounts of configuration using very simple declarations. And so next to our LND, we just want to install a CLightning, which is called CLN1. Which is the version of the chart, and we have some very simple configuration. So we want to use a new version of this is my own CLightning container that is also in my GitHub organization. And we want to actually, there is not much here except that we want to use all the latest trinkets, and we also wanted to use something called Trusted Coin. Trusted Coin is a plugin for CLightning, which is developed by a developer that you might have heard of before. His name is Fiat Jeff. And basically, he has developed this very useful plugin to basically have your Lightning node completely trust the block explorer for everything. So we are now in the hands of Blockstream, our overlords, and mempool.space to be able to get our data from the blockchain. So this is obviously not something this is something obviously that comes with its own set of trade-offs, but I consider it to be a very useful software, and that's something that you can use on testnet, something that you can use for small scale nodes, or something that you can use for demonstrations like this. And it is something like, because CLightning doesn't really have a neutrino, or at least not that I am aware of, you can use this Trusted Coin plugin to just fetch everything from blockstream.info or mempool.space. I think they have several options. If one gives an error, they go to a next one. I'm not really like into the details there, but let's install CLightning, or Core Lightning as it's called now. So that should be right now. So we've installed this, and this is something that we did while we were actually waiting for LND to sync. So let's have a look again to see how LND is doing, and this will be a kind of an interesting race. Which one will be ready first? And this is still syncing to this chain. It's now at 670,000. So I guess we should be there we should be there kind of soon, I guess. What is it now? 759. So we still have a long time to go here. So I guess, ladies and gentlemen, place your bets on which one will be the first, or maybe neither of them. I don't know what else that we're going to bump into. So yeah, this is basically something which you can describe as kind of like the phenomenon in software development, which is known as yak shaving. So I want to open a channel, but I want to do it right now, but LND is still syncing, so I need to solve another problem, and namely I want to install CLightning because it might be faster. And if you get into recursive set of problems like that, it's called yak shaving, because in the end you will have to shave a yak or something. I don't know, but let's see if our C Lightning node is already online, and oh, we have a problem because it's using image pool. It's an image pool backup. That's not great. Okay, so that's not good. Why is it using image pool backup? Because it doesn't have this. Does not exist. That's not great. That's not great at all. Why doesn't it exist? I don't know. Why it doesn't exist. Okay, so this is another example of yak shaving, because now I've run into a new problem, which is that it cannot find this Docker container. And I want to think about why it cannot find this, because I've actually done this morning. Push pull this. Let me have a look. Github.com, and we want to go to packages, and we want to look at C Lightning, and it's 0.12.3 if it's DPE C Lightning Docker. But why isn't it working? I have no idea actually why it's not working. This should be publicly available. I have no idea. Okay, I see. It's using the wrong. It's using the wrong Helm charts. It's pointing to the wrong repository. That's the problem. Let me quickly stop sharing and check what else. So 0.5 instead of 0.4. Okay, sorry about that. Let me share again. Okay, we are here again. Oh, sorry. Okay, so the problem was that I wasn't using something up to date, because there have also been some work in progress on this, because Fiat-Jaf's trusted coin library was also not. It was also actually interestingly affected by the bug of last week, because he was also using that library. He pushed some changes yesterday, and right here I copied it from the wrong place where it was still the old configuration, and we actually need to use 0.5.0 instead of 0.4.0. But this should be the right tag in any way, and then this should work. So it's now still building. So once it's being pushed, then this should be the Kubernetes should be able to pull this image. So to recap, what happened here is that I said to Kubernetes, okay, you want to actually get this container from docker.io /kiwiidb/C Lightning, which is a place where I host some of my containers, but I also have other places to host a container. And it was this tag does not exist in this place, and this tag exists in the other place that I just specified. And so that's the problem. So what Kubernetes is saying is that we cannot pull this container, we cannot pull this image, and we are backing off. But right now we are updating it with the new configuration, and then you will be able to see that it will create a container as it is doing right now. As you can see, this is all working quite fast. But let's, because a DevOps engineer is also doing multiple things at the same time, let's have a look at L&D and see if we're also already synced to the graph. This is taking a bit longer. I don't know if it's my internet connection or something else. Yeah, okay, here we are. We are now at 759, and actually we are synced to the chain, but not yet synced to the graph. But maybe we can now do a connect thing. And we actually want to do this with L&D, and hey, we are connected. And this command that I'm using is a shortcut to have a bash shell open in the container. And what do we want to do? We want to see if we're connected to LNBig, because we want to open a channel to LNBig. And we are actually connected to LNBig. So that's actually great news. So what we want to do is we want to go back to LNBig and now do this again, actually. and we want to buy some, I don't know, not too many. I'm not going to pay too much for this, but we also don't want small ass channels. Okay, I agree with this. I don't know about this prepayment. Okay, hold invoice. Let's send this using Alby. We want to pay. Okay, so that works. Now it wants our nodes info. So we need to paste in our pub key here. And we want to check this, and we want to create a public channel, and this seems all right. And actually, we want to connect to the LN big node. Okay, it needs us to do this again, I guess. And okay, let's have a look. Papa already connected. Yeah, we are already connected. But what's the problem? Or we don't want to be connected? I don't know. Okay. We want to disconnect and then reconnect or something. No, not connected. Okay, already connected. No, sorry, this is the wrong nodes. This was the wrong node. Disconnects. Okay. Okay, we are disconnected, so we want to reconnect. And we are now connected, and nothing happens. I don't know why nothing happens. Or, yeah, we are already connected. All right. Connect to the LM big node. As soon as you connect, you will immediately get the inbound channel. That's not true, or is it? And CLI list channels. Have we put in the correct node ID? It's taking a long time. We don't have any channels, but we did do a get info over here, right? We did do a get info over here, and this is our identity pub key. That's for real. Oh shit. Okay, this failed. Okay, let's disconnect. Let's disconnect from bolt.fun. From LNBig, sorry. Let's do an list peers to be sure. Oh, we still have the peer. That's strange. I don't want this peer anymore. Okay, that was the wrong node apparently. Okay. I don't know what kind of pub keys I'm pasting in here. Okay, so let's try that again. We want to pay €2. They're worthless anyways. And we want to paste in our own public key again. Sorry, our own public key. Get info. This is our own public key. Check it. Okay, we want a public channel. Doesn't matter. We want to connect this. Okay, we want to use LND. Okay, so yeah, it worked. We have opened a channel. So that's actually great news. And look at it. Look at it. This is our channel, which is actually opened. So this will, well, I guess this will be available in 19 minutes. I don't know. I guess it's, I don't think that we actually can, that we will be able to use it in this time because it's, oh, okay, we don't even know about it. LND is a bit slow sometimes. Sorry about this. Okay. Okay, we have peers, and I guess in some time LND will start to know about this channel. Why not open a channel with why not buy a channel for C Lightning node as well, right? And I mean, we're busy anyway, so we still have 45 minutes in this workshop, so why not do this again? Because I like opening channels. But basically, let's have a look at our C Lightning node, right? This one is much more lightweight, but you can do a Lightning CLI get info, which is the same command. So we are here sleepy throw, and then this is our node ID. And are we synced to the chain? I guess we are synced to the chain. It's already synced to chain. And here you can see the strengths of C-Lightning versus LND, because LND took a much longer time to sync to the chain as C-Lightning. But let's try and buy a channel for our C-Lightning node as well, right? I guess, why not? Buying channels today. We want to paste our node info here, and we want a public channel, doesn't matter, or maybe we want a private channel, I don't know. Let's take a private channel. We want to this might be a slightly different command. I think this is not going, okay, it is going to work, and we have the channel already. Lightning CLI list funds. Okay, so this does not exist. Oh, sorry, I don't need this when I'm already inside the container. And we have here channel D await and lock-in. So that's great news, right? We already have a channel, and does LND. So this is a 600,000 Satoshi channel, 675. That's open, so we will be able to use it once it's confirmed, I guess. I don't know if we are actually already able to use it. Maybe it's a turbo channel, but I'm not really sure about that. So, but that would be awesome. But let us first check our and as you can see, so now everything is duplicated. So we have a C-Lightning node, we have an LND node, we have 2 load balancers, or we even have cluster IPs. That's something else. But we have 2 load balancers with an external facing IP. We have 2 persistent volume claims for each of the nodes. As you can see, this has all been provisioned automatically. So okay, that's something good, right? So what we want to do is we were going to look at LND to see if LND already knew about his channel that I bought for it. Poor LND is always a bit slower. No, I'm kidding. Ah, shit. No, I'm not kidding. I guess it should. Oh, it doesn't know about the channel yet. Okay, so, but I guess it will know about the channel once it's confirmed. I don't know about this. So, but let's Lightning CLI invoice. No, or yeah, invoice. We need to have it a label. Label 1000 millisatoshis. 100. Okay, this is from the back of my head. 100 satoshis or 1000 satoshis. Tests. Does this work? Should be positive. Okay, so this label, the first parameter, because you can also use keyed variables, I guess. The first parameter, millisatoshis, or you can just write 1000 sat here, and then you can give it a label, which needs to be different every time, and you can give it a description, which is called test. So now we want to generate this, and it should give us an invoice, and then we can try to pay this invoice. But it's warning us that we have insufficient channel capacity to pay for this invoice. So that's a problem. But yeah, we have to wait for confirmations, I guess, but we can wait for confirmations for a long time. So that's a bit of a bummer that this doesn't work with turbo channels, which we would have been able to use immediately. But yeah, I guess we need to wait for confirmations, which is the life of a Bitcoiner, I guess. Okay, so list funds. We want to look at when is the next block coming. I guess we want to... The man who's there at the mempool, right? Sergey, are you watching? Yeah, okay. So we want to look up this transaction in the mempool. This one is still not confirmed. Obviously, it will only be confirmed in 19 minutes. So I hope we're not unlucky, because I guess and this one will also be confirmed in 90 minutes. But I guess, yeah, it's not sure if this will confirm before the end of the workshop, because so that's a bit of a bummer. But yeah, in the end, we need to wait for confirmations. So that might be a bit too late. But basically, once it's confirmed, then you can use it, and you can use it to pay for it, I guess. But it's still unconfirmed, so I guess we won't be able to do that. But yeah, that was basically, we've already covered a lot of ground. So Yeah, I think it would be a bit too much to have someone jump in and open a turbo channel to us, but it would be possible in theory, I guess, or maybe a hosted channel would also be possible in theory using a C Lightning plugin. Yeah, that's something that you can also use. Hosted channels would be interesting for a setup like this, actually. So people are always asking why hosted channels. Well, this is something that you can really use hosted channels for. Suppose you have multiple nodes running on Kubernetes and you don't want a single point of failure when one of the nodes goes down, or one that you always want to be able to receive. So what if you have a one small lightweight node that you only have okay, so you need to be able to really make sure this you need to build this node very lightweight, but it doesn't really need to be a real Lightning node. So, for example, BottlePay has some thing called LNMux that you could use for it, but you can achieve the same thing with hosted channels, I guess. And let's say that you have this you have this very lightweight nodes that only has hosted channels to your real Lightning nodes, let's say 3 of them. And then when one of these are all scheduled on different hardware, and when one of these goes down, then you can always like still receive and pay for invoices as long as there is one of these intermediate nodes that are still up. The reason to do this with hosted channels is because you don't want to make Bitcoin transactions. You don't want to open channels with yourself. That's not very useful. You're the same entity as yourself, so there is no need to lock up liquidity in channels with yourself. So that's something that hosted channels might be very useful for, in my opinion. What was I saying? Yeah, I was just giving some background information, I guess, because we still have 40 minutes to go. Yeah, Ed, I don't know if you want to jump in, if there are any questions from someone, or if you have any questions.
No questions currently yet from the audience.
Damn, I hoped for some good questions, but yeah. Yeah,
Well,
did you follow along? What do you think about it?
Yeah, I followed along as much as I could. I'm obviously not the most technical person, so it's hard for me to fully follow along. But it was kind of interesting to see those different sync times between
LND and
Core
C
Lightning and LND. That's actually something that I've seen.
Obviously.
Before.
But yeah, we are cheating a little bit, I guess, because we are using the Trusted Coin plugin that just that's really because we are. And LND is using neutrino, so it's also cheating, but it's less, I guess. But yeah, it's indeed that in certain ways, Core Lightning has different trade-offs than LND, but it's more performant. But the LND has a better developer experience and so on. So yeah, there are different trade-offs to be made there. Yeah.
So you mentioned this is currently what sort of Alby is using for their infrastructure. At what point did you guys make the decision to sort of switch over to something like this, or was it always kind of that way?
It was at the point that they hired me. Yeah, so they hired me specifically to do this, really. So it was at that point that they hired me. So this was, we're talking about January, like December, January, February of early this year. So December 2021, and then early this year. When I started working on it, and this was the first thing that I did was install Kubernetes and so on. So yeah, that's at that point. And then we migrated everything that existed before that, which was not many users that were running on infrastructure that Boomi was running, and we migrated those to the new infrastructure.
Right. So if I'm a founder of a project, I'm looking to sort of get this type of thing set up. Like, at what point do I look to sort of transfer my business from a slightly smaller, maybe manual sort of handheld run infrastructure to something which is a little bit more beefy with regards to its.
Well, it depends what your ambitions are. If your ambition is to become as big as MetaMask, this is our ambition, then it's better to be sooner than later, I guess. If you are planning to scale, then you might as well go for it. But I guess it's really, I wouldn't say, it depends on the amount of transactions, monthly transactions that your app is handling. It depends on how many users that are using the app. But let's say that, I don't know, let's say I think that this should be standard practice for all kinds of early stage Lightning startups, I guess. If they have the resources to do it, to hire the engineers to do it and maintain it, I guess.
And is it still possible to have the same level of transparency when it comes to sort of showing the capacity of your nodes, the inbound, outbound liquidity, these types of things?
What do you mean,
transparency? Thinking about a service like Amboss, you sometimes see
Or what do you mean? What, I don't understand. Our nodes are now, you can look them up on Amboss. They are live. So I don't know what.
Cool. So you can have a high level of transparency, basically.
Yeah, obviously. These are real Lightning nodes. That is the same if we just installed them in about an hour, and it's the same as if you would run it on your Raspberry Pi at home. It's the same as a voltage node. It's the same as any node. So we are a real full Lightning nodes with no trade-offs whatsoever, except that we are running on infrastructure that is really owned that is in some data center in Amsterdam right now. Yeah. So this is really, we made our own, this is like do it yourself voltage platform or something. So this is really what voltage is also doing behind the scenes. Well, I don't know, but I guess that they do this. If you schedule a node on voltage, everything that I just did manually will be done automatically. But I guess they will use the exact same infrastructure, Helm, Kubernetes, and so on and so on. Yeah.
Okay, awesome, cool.
Yeah.
Well, so I guess if anyone is looking to sort of get set up, Quinten is your guy. This is a really cool workshop. Did you want to try and shave some yaks, or I can't remember what you can run a little bit over if you wanted to wait for those block confirmations, but
let me because the sun is in my face, damn. Okay, it doesn't really matter that the sun is in my face, I guess. Okay, so let me just take a look at if we have some confirmations. No, it's still okay. It's in 8 minutes. Oh no, it's still going to take some time, I guess. We need to wait for the confirmation, so it's not really, but yeah, it's not going to happen anytime soon, I think. We can do, I can install other stuff, I don't know, but I think it might be enough for now. So we can install Nginx to make a real website. We can install ThunderHub to have a ThunderHub to look at our nodes. We can install LND-Mon to monitor our nodes in Grafana. We can install LND Backup to send the static channel backups of our nodes automatically to a different cloud provider, so we have redundant backups. What else can we do? We can install LND Hub, which is lndhub.go, which is the infrastructure that we are using to power the Alby hosted wallets. And that you can also use as a backend for your Blue wallet. And that's also something which needs which you can run alongside your Lightning nodes in this cluster. But it's really all the same principle that I showed with the two files. So first you have the chart.yaml, which defines what services that you want to run, and then you have the values.yaml that describe the configuration of those services. So this is all really the same principle.
Cool. And so you mentioned at the beginning of the talk, you were saying that there are certain costs that can come along with sort of running these services yourself. Do you want to maybe talk a little bit about what those are?
Yeah, certainly. So right now we created a cluster. Let me share my screen again. Share my screen. Yes. Okay. I want to share my my screen. Okay, let's share my screen. Can you see it? Okay, so what do we have here? Let's take a look. Where can I find this? I have no idea. So let me just look at the billing. So no, this is sorry. So this was the wrong. Okay, so do I have something here? No, I don't. Okay, sorry. Let's go. So this would cost around. What we did right now is really beefy because I didn't want it to fail because of too few resources. But what this actually costs is this Kubernetes cluster costs $72 per month, which is quite pricey, of course. But if you're a startup and you have some funding, then it's not that pricey at all. But you can scale this down. You can have the Kubernetes cluster for $12 per month. It's going to be a bit harder to make everything fit, but it's possible. Then what else do we have here? You can have all kinds of things. We have the load balancer. So the fact that DigitalOcean gave us a real IP address, and these ones, I think, what do they cost? I have no idea. Okay, so this one costs $12 per month, and I think this is times 3 because we have 3 nodes in our cluster. So this is actually times 6, so it's quite pricey. But if you only have 1 node, then it's also only 1. And this is same for the volumes, but that is really cheap. That's not something that costs a lot of money. You can, if you create a volume, let's say 100 gigabytes, we only have 5 gigabytes. And that only costs you 50 cents a month. So we have $1 a month for the storage, which is dirt cheap. So these are what we just did. You are looking at about $200 or something of monthly cost, which is quite pricey. But it's just because I didn't want it to fail for not many resources, and I will tear everything down. So my PayPal account doesn't get hit with this. Or at least not with this much. So you are looking at, so this is enterprise level. You are looking at costs which are not for average people, of course, which are overkill for average people, but that's why it's enterprise level. Yeah.
Of course. But I mean, I guess if you compare that $200 a month compared to your standard, I don't know, Visa network costs or
So we are basically but for $200 a month, you can have basically have an app which you can run something which is as big as Wallet of Satoshi on that. If you really if you try a bit, I think that's possible. Maybe they have even a bit higher cloud costs, but for $200 a month, you can. You can really power some really high throughput Lightning systems on there. So you can be a very big, world-class player, I would claim. Yeah.
Yeah, I mean, it's kind of crazy that you can run infrastructure of that level on that type of cost. Like you said, maybe it's not a suitable solution for someone who's kind of setting up their side project, which they're maybe looking to move into a full-time project. But this is definitely a path where people could kind of migrate into. Are there any other ways that you would kind of recommend, other than sort of decreasing something like the node count? Are there any other like smart hacks that you could reduce these costs, or is that just kind of what it is?
Yeah, of course, there are always smart hacks. So you can try different cloud providers. I don't know, Google may be cheaper. You can try Amazon or Azure, but I don't know if that will be cheaper. You can run your own Kubernetes cluster. So now we just use DigitalOcean to manage our Kubernetes cluster for us. We just said install Kubernetes cluster, but you can do this is also Kubernetes is also an open source project. You can install a Kubernetes cluster yourself. I cannot do that. I'm not technical. I've never tried it. I'm not technical enough to do that. But in theory, if you have a couple of Raspberry Pis or even one Raspberry Pi running laying around, if you have some machines yourself, or you buy some cheap virtual machines on some other cloud provider, you can install Kubernetes yourself, and then you will have less server costs, but of course you will have more time that you need to invest yourself, and you also need to be able to do that. So that's something that you can do. But other than that, saving costs and running Kubernetes in the cloud is not two things that mostly go together, I guess. Yeah. Yeah.
Cool. And then I guess my final question would maybe be kind of around sort of backups and stuff. You might have actually covered this in the workshop and it might have just gone over my head, but are there some recommended sort of tools or methods for sort of backing up, migrating and recovering clusters and stuff?
Yeah. Obviously, so one thing I did was first I just did an lncli create, which was off screen, but which will give you the seed of the nodes, and then you obviously need to back up that seed on paper, or I don't know what you do, but as you would with any normal node. And then LND will also automatically create the static channel backups on its own disk. But there are other things that you can do, as I mentioned before. So you can run some software, some supporting software, which I also have in my Helm repositories, which is called LND backup. And this one is able to stream the static channel backups as on the fly. So every time you create a new channel, every time you close a channel, it streams its static channel backups to to a cloud provider, to something called S3 or generic storage backend. So what you can do to make this really robust is, let's say we are running on cloud provider A with our Kubernetes cluster, and we actually stream our static channel backups to cloud provider B. So once cloud provider A kicks us out, or for some reason they don't like what we're doing, or it's against the terms of service, or just some technical failure, their data center burns down, I don't know. If you still have the seed, if you still have the static channel backups, then you can recover all the funds that are in the nodes. So, or in theory, of course, as static channel backups come with their own trade-offs. So that's something very powerful that you can do in this type of situation. Other backup strategies. Okay, so I mentioned Postgres. So both the three big implementations have support for Postgres. I mainly have experience with using Postgres on C Lightning, which works really well. LND also has starting support for it, but it's not quite stable yet. But if you have a Postgres database, then you can have this Postgres database also managed, maybe by DigitalOcean, maybe by someone else, and you can really make this like Postgres is a technology that is meant to be really robust, that is around for a very long time, this database. So if you're really looking for a high level of like reliability, where to store your channel data, then I would go for C Lightning with a Postgres database right now, or maybe Eclair, but I don't have experience with that. So these are the main things that you can do for backups.
Cool. Okay. I mean, that's is really important. I mean, we sort of ran into some backup issues a couple of weeks ago with our database, and just always good to have that peace of mind.
Yeah, that's true. Yeah, that's true.
But cool. Is there anything else that you'd maybe like to touch upon just before we finish?
Let me just check if the transactions. No, it's not confirmed yet. Of course not. No, I don't want to mention anything else. So I think we are done here. Thanks for having me.
Cool. Well, thank you so much for coming along. I hope everybody enjoyed it. There was definitely quite a few people who tuned in over the last hour and a half. For people who are watching this back on playback, obviously, this was Quinton's way of setting up, or an introduction to sort of Kubernetes and setting up the sort of infrastructure for sort of enterprise level Lightning. Any final words, Quinton?
No. So I guess see you in a couple of hours, or in an hour, for the Meet the Maker session, I guess. Is that also live?
Yep. Yeah, we'll be live for that. I'll
Okay.
start being in about an
Okay.
hour and 20 minutes, I think.
All right. So one thing that I would like to say, so if you are interested in all of this, if you some things might be familiar, if you are a DevOps person looking to get into Lightning, please reach out. Thank you for yeah. Please reach out to me, to Alby, to Boomi. We might have some things, opportunities. I don't know, but it's really hard to find people. So if you are interested in this, please reach out. On Telegram or on, I don't know, whatever. I'm not on Twitter anymore, unfortunately, but I guess please reach out to Alby if you're interested in this, if you saw this video and you're interested in this kind of things. Please check out our Alby GitHub repositories. Most of what we do is open source. So, and yeah, also the repositories that you saw in this video, these are my personal repositories, but yeah, please reach out. And that was it, I guess.
Cool. Well, I will post that link to the Alby GitHub for anybody who's interested. I'll just post that in the comments now. And Quentin, where can people find you? I know you're not on Twitter anymore.
No, you can find me on my website, quintendebakker.com. You can find me on quinten@getalby.com, which is my work email. You can find me on Telegram, which is quintendb. You can find me, my Alby Lightning address is kiwiidb@getalby.com with I don't know, it's spelled, maybe I need to change it, I don't know. But yeah, I'm hanging around in the Bitcoin design Slack. I'm hanging around even in the L&D Slack. Yeah, that's it. But I guess to be concise, I would say Telegram, QuintenDB.
Cool. Great.
Yeah.
Well, look forward to chatting with you in just over an hour as well. Thanks again for
All
coming
right.
on.
Yeah. All right. Thank you. See you. Bye.